My name is Sahdev Zala. I work at IBM, and I'm an open source developer for almost 10 years now. I started my journey with OpenStack, where I was a core contributor, and then moved to Kubernetes, where I'm a maintainer for the etcd project, which is the data store that is used by Kubernetes. I also lead IBM cloud provider in the open source side in Kubernetes. And I was also a technical committee member, some time back. And I have a wonderful co-speaker here.
Hi, everyone. My name is Kristina Krasnolobova. I'm a cybersecurity engineer for Sentara healthcare. I'm a security enthusiast. If you're working on a project and you might want to have your project most secured and you think I might help you in any form or fashion, feel free to reach out. I'm a community volunteer. I volunteer in several community events. In fact, I volunteered with All Things Open several years ago. And I'm a Besides Nova organizer. I started as a volunteer and a few years ago transitioned to be an organizer.
Thank you, Kristina. So the agenda today, we will start with what's going on with the open source security. We will deep dive into the assessment of the open source security and security vulnerabilities. We'll talk about the secure software development lifecycle, and we'll share some of the open source tools that can be used towards assessing the security. All right, let's start with the current status of open source security. And I won't take much time here, but I think this will be useful, just to get started, right, why we are here. So early this year, OpenSSF, Open Source Security Foundation, published a report, and I just grabbed some of the data from there. I would highly encourage you to read the real report. But they surveyed more than 500 organizations. Out of them, 41% of orgs, they say they don't have high confidence in the open source software they use, especially in the security side, right? Security of those software. The second interesting fact is average application in development, they have dependencies, and this is high dependencies, right? The third one is, time to fix vulnerabilities in open source software projects. That has steadily increased. You can see it like more than double from 2018 to 2021. Now, one of the factor is pandemic for sure. I was at the KubeCon last week in Detroit, and they shared some of the stats. And one of the things was we lost about 20 to 25% of contributors because of pandemic, right? So hopefully this will improve. But this one and the next one, those are very interesting. So 51% of organizations, they don't have a security policy for the open source software development, right, the contribution-wise, or the usage. And 30% of those organizations, they recognize that no one in that team is taking ownership, right, and responsible for addressing if something come up. And that's somewhat dangerous, right? This case, if something unexpected happen, you lose your sleep for days, for weeks. Remember what happened end of last year? Log4j, okay? We know what happened, okay? Talking about Log4j, the Apache Foundation, where the project is hosted, they rated the vulnerabilities, which is Log4Shell and Log4j, as one of their highest critical vulnerabilities. And Log4j, I don't know if you heard about the Securing OSS Act of 2022, right? So that is, in response to this Log4j and Log4Shell vulnerabilities, U.S. government is taking it, very sincerely, right, seriously. And this act was introduced, I think, early this year. So the federal government, which is one of the largest consumer of open source software, it makes sense for them to, to act, to manage its own risk, right, associated with the open source software they use. And then, we'll talk more, but seems like most of the software, regardless you think you are using open source or not, but most of the software you use, they have some sort of dependency on the open source libraries, right? So this is a good step from the government, right? That they're thinking about it, and not just for the federal, but supporting the private sector and public sector as well. And part of this proposal act, and I would again encourage to read I think it's 3-4 pages of documentation, which is great. I just got a couple bullets from there just to share here. But part of this, the CISA will develop a risk framework to evaluate the open source code used by the federal government. So the evaluation, the assessment of open source software is critical. We all should feel a little uncomfortable in using it without knowing what's in there, right? So I try to simplify how do you assess the open source software security. Also have a video out there, it's like 5 minutes video talking about the security assessment. But I try to simplify as in like 3 A's, just to remember it easily. And those 3 A's are, that stands for assess, adopt, and act. They are interconnected. There is no specific order you can look at it. But hopefully this helps to remember what I'm talking here, right? So many times, when we think about assessment of open source security, you just think about right away about the security features, right? Like, oh, let me see what kind of security features out there. Let me look into it, right? But in reality, there are multiple things that you need to be working on it, not just straight to the security. Yeah, yes, that is critical, but then other things, right? So let me just explain a little bit on the assessment part. I would start with the license, right? A good open source project should have a clean, clear license that you can understand. And you should understand it before you start using it, consuming it, right? Because you don't want to run surprise after, some days, some weeks later, like, oh, this is not what we wanted, right? Or they don't let us do this or that, right? So you start with the license. I mean, if that's something you think you're not comfortable, I think that's like a sign to, dig further there, right? The second is open governance. I mean, what do you think? There are thousands of open source projects out there, right? You create something, GitHub, oh, mine is open source project, right? But the open governance is very important, which means, there is an open collaborations among the contributors, right? It is not controlled by one individual or 2 individuals or like one vendor, right? You need to know what's the governance. If you adopt the project, you start using it, tomorrow you run into an issue. And you say, hey, I want to provide a fix for it, right? Are they even willing to take your fix, right? Like, hey, no, you cannot contribute, we own it, right? And it's open source, yes, but, our governance doesn't let you do this or that, right? Also, are they having open collaborations, right? What's going on? The decision making, it's not something just 2 people are making decisions and changing things, as they like, right? So you got to make sure the governance. The third thing is the state of the development for the particular open source project. According to the research surveys, it's found that projects that are abandoned, right, not being maintained well, they pose the highest security risk, right? It may be a great project out there, may be used by many people and was in good shape some, at one point of time, but then, eventually nobody's working on it, right? Well, that's not good sign, right? Those projects pose high risk, and you should know it. And some of the areas where you can find it out is look at what are the issues that are open. I always actually do it myself, right? If we are part of my, like, say, we're trying to have some dependencies, you can look at it into like, hey, okay, what's about the project, right? What are the open issues? What's the activities, right? What are the open pull requests out there? Even if there are any, in many projects, it's like, oh, the last pull request was 3 years back, right? And nobody ever then contributed. And the third thing is, the merge pull request, right? Give it a look, right? Merge and see the quality of reviews, what kind of code's being merged, okay? The maintainers, they should do a good job before they merge any pull, any code changes. But you can just take a look at the few of them and see, hey, are they really serious or any kind of code's being merged, right? That's again very dangerous. Once you feel comfortable, the second aspect is assessment of the security, right? And again, you start with, I would say, architecture of the project. Look at the security model, right? And also, how easy to use those security features that are being provided. Can you really use them, right? Policies, that's important. So the project I work, we have a team of people. They are responsible for the security side, okay? Like the policies are like, okay, if you run into any security vulnerabilities, let us know by sending email to this mailing, small mailing group, right? Let us know about, if it's something that we shouldn't be discussed publicly before providing the fix, right? If it's something very serious, right? So how do you report issues? Who's gonna work on it, right? Are they doing any periodical improvements, right? A good project should do it, right? Every here and then, like security audit, or other things, right? So, like I said, there should be a good documentation on the policies that you should refer. A code review. One of the biggest thing is with the open source project, the code's out there, right? It's not a proprietary product. You have everything is out there. So review the code. I'm going to deep dive into that in the one of the next slides. So not going there, but code review is very important. And then SBOM, software bill of material. That's another thing that's being grabbing a lot of attentions lately. And it's very important to deal with the dependencies. Again, we'll talk more onto that. The second thing is, okay, you are comfortable with the project, your assessment, right? Depending on characters, like some of these things may be more from your own side, right? From your own security team. Comfortable with, that doesn't mean you just start using it and forget about risk, right? That happens. Like say in my previous slide shows like a lot of people, 30% of work, they say we don't have anybody responsible, after we start using it, right? So there should be policies, in-house. Who's gonna own it, right? Tomorrow, if there is a problem that your team discover, you run into it, and you report it to the upstream, by any chance, if it takes longer from the upstream side, do you have skill to fix it yourself, right? Upgrading the versions, right? We see like, oh, the current version is 3.6, and people still use like 2.5, way back, and in between, there are so many fixes, right? Enhancements, but improvements, security-related fixes have been done, and you never, upgraded to the newer version, and it can get out of your hands, right? If you don't stay on top of at least the supported version. Right? It doesn't need to be the latest, but it's something that is supported by the upstream project. Policies even around the contributing, right? If you're contributing to any open source project. But talking about that, third A is for ACT, right? The security of open source software is not responsibility of maintainers or contributors. If you are using it, it's your responsibility as well, right? It's free to download. You can start it. You can fork it, do whatever you want, but you should take a responsibility as well. And by acting to contribute, there are two main things, right? Maybe more, but you are staying on top of what's going on, right? Now, depending on the size of your team, like, hey, we are a small company, we don't have much of the resources, understandable, right? But, you can contribute in many ways. It doesn't have to be a full-time contributions with writing, new codes or, new features. It can be by reporting issues, by triaging issues, right? Even being part of some user group, right? So there are multiple ways you can contribute, through code, through no code, but it helps you to stay in touch with the project and what's going on. And by contributing, you're also giving back to the community, which is very important. You know, that's how these open source projects, they thrive, right? It's the community, that's the lifeblood of the open source projects. All right, so OWASP, the Open Web Application Security Project, I'm sure people know it, right? It's one of the, I think I would say, if not one of the best places to learn about some of the security things. So they regularly they do revise this, but they publish the top 10 areas that are most critical part of the security. So while you are developing software or even these areas as part of your review, right? The areas that you got to really pay attention, because these top 10s are the out of many of the security weaknesses that we see. And along with OWASP, the MITRE also published the top 25 weaknesses. That's other areas to take a look. So I'm not going into all these 10 different areas, but they are important, right? So some of them are very, very common. We know that, hey, access-related issues, authorization, authentication-related issues, right? Cryptographic failures, but also the injection, right? Data validations. I think that's one of the things that, like, say, you're developing, reviewing, you got to review that very carefully. That's the injection part. Design, logging. We talk about again Log4j and in general. So these are, like, say, we're not going in deep into these areas, but something I wanted to share. That takes us to the code review and security audit part. As I said, upstream projects, I work on multiple projects so far in my career in open source. Reviewer role is very important. Okay, in many cases, it's actually even more important than actually contributing the code, right? So it's something that you should feel proud if you can review the code. It's a skill, right? And maintainers or owners or committer, whatever we call, right? Different project call is different ways. But in all these good projects, they require you to be a good reviewer before you get into the ladder, right? Up into that contributor ladder. So if you're trying to contribute, reviews are great ways to contribute and be visible in the project, right? And then again, from the assessment perspective, there are some of best code review practices. Of course, static review, right? There are tools to catch on the code, like shadowing, variable shadowing, for example, unreachable codes, right? Whatnot. And then there are dynamic review, where you're gonna use different tools to run on the while you execute the code, right? For example, fuzzing. That's where you're gonna the injection part I mentioned earlier. You validating by randomly creating a lot kind of different inputs and making sure that's working. And then there are many other tools that Kristina will show later in the talk. And then always keep in mind that there's no alternative to manual review. Tools are great; they give us all kind of insight, but you definitely want to have a manual review and analysis of the results, right? Dependencies, right? I'm sure no need to ask, but if you are a developer, you are using some sort of third-party tools, right? Like I said, average application has some number of dependencies. So it's important to understand those dependencies. Again, I would give the example of Log4j, right? When that vulnerability came out, the big organizations, right? Everyone got impacted, I guess, because Log4j is a very popular logging tool. So there are two things, right? One is like, okay, are we using Log4j? Like, okay, how do I find it? No idea, right? Okay, I can scan through my code and see where, if we have any reference or whatever, right? The second thing is, are any of the software that I use, they use Log4j, and I have no idea, right? So that's where this software bill of material comes in picture. It's like an inventory of your software, right? It's the same way, inventory for your car, right? Different manufacturers, different parts. Something goes wrong, you know who to deal with, right? It's same thing with what we eat. Like, okay, I'm eating something. I'm gonna make sure I know what's inside. I'm not just gonna randomly eat it, and that can be dangerous, right? So this is important, right? Software bill of material. It gives you the record of what are the libraries that's being used, additional information about like licenses of those libraries or tools, right? And that should be provided, like the FCD project, we have bill of material, right? But if it's not there, then it's something you should ask, right? If you can, or if there are tools that can help you to generate it, and that's something you can take a look and stay on top of the inventory for your software, right? So something goes wrong, you can refer to it. With that, I would like it to hand over to Kristina.
So some of you might be familiar with software development lifecycle. Some might be already implementing that model. The definition, or SDLC, was introduced somewhere around 1960s, and it was aimed for large business companies. And since then, a lot of various SDLCs were created and introduced. Some of them have more phases than others. Generally, we can group them in 5 different phases. Requirement gathering, that's where we answer questions as to why, what, and for whom we're creating software. Design, where we think about how we're going to create software. Development part, that's programming part of the life cycle. Testing and validation, where we're verifying that software is working as intended. And release and maintenance is deployment, configuration, and monitoring of your software. Secure software development lifecycle, essentially, what you do is you take software development lifecycle and enriching each phase with security. So because I work in security, I could probably say a million reasons why I think security is important for any project. But when I think in terms of software development and open source projects, those are 3 things that come to my mind. Time is money, said someone much smarter than me a long time ago. And the companies that care about remediating vulnerabilities, they yield higher quality projects. They also, in the long term, save the time. Another bullet on my slide is very relevant to open source project is because we're sharing our project with the community, we want to make sure we're not putting our end users at risk by sharing vulnerable projects, vulnerable software. We want to think about our end user and how to protect them. And the third, open source project is great because it allows collaboration, diversity, yields higher quality projects, great fresh ideas. So more eyes on a project yield into more efficient security flaws findings, as well as more effective security holes closing and remediation. Adding security into traditional software development lifecycle could probably be its own presentation, but I'll try to run through the steps briefly and tell you what could be added to the process to secure the software development lifecycle. So requirements gathering. You can add security requirements to this phase and think in terms of CIA triads. Think about confidentiality that your project needs, integrity that your project needs, availability. Security risk assessment is step where you're thinking what kind of threats and vulnerabilities your project potentially exposed, and you're thinking how you're going to remediate it. And privacy risk assessment and risk level assessment, not all projects probably relevant to all projects, but if you're dealing with PII, this is something you should look into. Design phase. I really love analogy that CISSP book does. Imagine you're going to war, going to battle, and you have a suit of armor, but it's only protecting half of your body. Half of your body is vulnerable and exposed. And this is what essentially attack surface analysis is. You have to determine which parts of your body are exposed and how to protect them. Threat modeling is process and where you doing a the scenario-based exercises to determine what threat actor can do. Pretty much you thinking like a bad guy, what kind of damage could be done, and what can you do to remediate that damage. Development phase. This is the most critical phase and the phase where you can avoid pretty much all known at that time vulnerabilities by implementing secure coding. My co-speaker mentioned before common weaknesses enumeration by MITRE, top 10 OWASP vulnerabilities. If you're not familiar with them, please get familiar. It will benefit you in the long run. I know implementing security into the project and secure coding is not an easy task, but it's a skill that could be developed over time. Testing and validation. When you do your testing, include security testing. There could be security attacks, security pen testing. It could be a static analysis, dynamic analysis, automated use of automation tools that could analyze your project and give you reports. And last but not least is release and maintenance. Keeping up with new vulnerabilities that's always evolving is very important. So after you deploy your project, we recommend to monitor on new vulnerabilities that come up and release patches, hot fixes, and updates. So we talk about secure software development life cycle, and this is if you have starting project from a ground up. But what if you already have a project? Is there anything you can do? The answer, if you would guess, is yes. You can do vulnerability assessment. I'm presenting on a slide vulnerability assessment definition that NIST using in some of their documentation. But if I had to describe it, I would probably say it's a systematic process of assessing your project on the presence of known vulnerabilities and coming up with the plan on how to remediate them. So if you didn't use secure software development lifecycle or never done a vulnerability assessment, you're probably way past you on closing your existing security holes and vulnerabilities. And even if you've done both, you could always benefit from vulnerability assessment because it's almost daily we see the new and emerging vulnerabilities and threats come up. Our end goal here is to be smarter than the hacker and mitigate vulnerabilities before they're being exploited. I hope you're all convinced that you need a vulnerability assessment, but where can you start? This is a fraction of the tools that are available for open source projects. They offer various analysis. It could be static analysis, dynamic analysis, just whatever you imagine, it's out there, I promise. And the best part, it's free, so there's no reason not to use them. Get familiar, the OWASP published a very good article that has a good list of all of them. Get familiar with that. And the last thing I wanted to share, just an example what one of those tools can do for you and how you can benefit. This is GitHub code scanning tool. It does a static analysis of your repository. I will be honest, I didn't do deep dive into this tool, but I created a file that had a vulnerable Python code provided by Snoopy Security, and went to security settings, configured code scanning, and this is the alerts that I received. I thought it was great that they give you severity level, they give you CWE number, and I don't use GitHub very often or hardly ever nowadays, but I was very pleased and surprised for what they're offering for free for a community to use. And this would be my last slide, and we can probably thank you and take questions if you have any.